in the Ocean Day, we have to think that the contribution of oceans for our life, and we have to be in turn. We have to do many activities to keep the oceans healthy and cleaner. So, with that few words, now I invite Dr. Chandrasekaran sir, to deliver a lecture on catalyzing. Actually, the theme of this World Ocean Day is catalyzing actions for our ocean and climate. So, we have requested sir to give a lecture on for climate resilient fisheries. So, sir has kindly accepted that with a short period of notice. So, now I welcome Dr. V.S. Chandrasekaran sir, who is the. Before that, I would like to introduce the chief guest, Arun Rain. Please introduce the chief guest so that they should know, audience should know. Thank you.
Dr. V.S. Chandrasekaran is a retired principal scientist from the Central Institute for Brackish Water Aquaculture, Chennai. Sir has a teaching experience of 23 years, including 13 years of experience as assistant and associate professor in College of Fisheries, G.B. Pant University of Agriculture and Technology, Pantnagar, Nainital program. And Sir has a research experience of 37 years with a total of 19 research projects have been completed. And Sir has done a total of around 200 publications, including 12 books and book chapters, 51 research papers, translated the FAO manual on fish farming in Tamil, and co-published with FAO. And Sir has visited various countries like Bermuda, UK, USA, Thailand, Malaysia, Singapore, Dubai, Abu Dhabi, Israel, Jordan, Egypt. And Sir has participated in 12 training courses, including 2 international and 10 national training courses. In 1984, he has undergone oceanographic training in research vessel Kavashani covering east and west coasts of India and Sri Lanka. Sir has been a member of several professional societies, including member of 9 national and 7 international societies related to fisheries. Then member of Executive Council of 1 national and 4 international scientific bodies. And Sir has served as the editor of the International Journal of Fisheries and Agriculture, Academic Journals, Nairobi, Kenya, with effect from 2010 to 2017. And now I would like to welcome Dr. V.S. Chandrasekaran sir to deliver his lecture on the topic Catalyzing Actions for our Ocean and Climate Resilient Fisheries.
Next question. Oh, yeah. So if you see how the climate is impacting the marine environment, there are mainly 2 parameters. One is temperature and another one is ocean acidification. Temperature is the direct increase of the temperatures because of the greenhouse gases. Density is increasing, greenhouse gas density is increasing, and because of that, heat is being captured repeatedly within the atmosphere, and because of the temperature is increasing, like heat waves in land, now we have heat waves on oceans also. So this is how the surface water temperature is increasing very much, and it makes a lot of problem with the biological systems in the oceans. And the ocean acidification is due to the excess of carbon dioxide which is being released into the atmosphere. It gets dissolved into the sea and becomes a carbonic acid. That is how the pH is getting reduced. Naturally, it should be alkaline. Whatever the medium is alkaline, it is good for us. Even our own body slightly is alkaline. Okay. If it goes acidic, then we are not well. Yes. So you see, there is no much difference between the pH. It's not like a 7, 8 like that. 7 is neutral and 8 is alkaline. So 100 years back, it was good above 8, but by 2100 it become less than 8. So even that much of small difference in the pH matters. The organisms are mostly the phytoplankton, zooplankton, which are having silicon and calcium. All these are being affected because of this ocean acidification. Next slide, please. So as I said, 93% of the energy coming from the solar radiation that is being absorbed by the oceans, and 44% it is being absorbed by the ice all over the polar regions and the mountain depths like Everest and all. And atmosphere actually absorbs 1%, and the land, the terrestrial land is actually absorbing only 2% of the total solar energy. So this is the heat budget, which subsequently affect all the, or which gives a conducive environment. See, supposing we are talking about climate change and this greenhouse gases and all, if that shield is not there, or that carbon dioxide, if it is less, or it goes negative, if it is becoming too less, what will happen? Global chilling will take place. Now it is stabilizing. Because of the industrialization in the past 1 century, the carbon dioxide and other gases is going up and it making the imbalance. Otherwise, if it happens negative also, global chilling will take place. So actually, in the past, if you see, take the history and see, ice ages were there. Many ice ages were there. In geography, geological time, if you see, millions of years back, ice ages were there. So it was happening and no human being that time. But what happens now, we are being affected because of the man-made problem of climate change. Next. So how the extreme weather conditions, like I said, El Nino and La Nina, which is warming and cooling of the world oceans in the South Pacific, which affect the environment, particularly in the marine environment. From the warmer areas, the number of organisms migrate towards the conducive environment or colder regions, and the species migration it is also there. And it will happen in reverse is cooling is taking place, but now it is warming only. So because of that, distribution of zonation of fishes, each and every organism or plant, it's having its own zonation based on the physical chemical parameters of that area. Okay, if that is changed, then they have to move. Whatever the fish they can move, they will move out. The sedentary organisms, the organisms which are being attached, they cannot move within the physiological limit. They will stand. Beyond that, they will die. That is the situation. And increase in salinity in the near surface waters in hotter area. What happens due to the increase in temperature in tropical warmer areas or hotter areas? Because of more of evaporation, salinity increases. And the opposite is happening in the polar regions. Because melting of ice becomes more and dilution takes place, and the seas which are nearer to polar regions, they become diluted, means less salinity. Here, more higher salinity, and there, very less salinity. Today, Oceans Day by United Nations headquarters in New York, USA, they have celebrated yesterday itself in the headquarters, and today they are telecasting all the happenings of the celebration. In that way, ocean is really an ocean for living organisms in the sense of biological diversity, and of course, no need to tell, genetic diversity is also quite large, and it's full of biological wealth organisms like fish wealth and mineral wealth and ecosystem services, different type of ecosystem services, oceans are provided. More slide more. Next slide. Next slide. Next slide. Oh, yeah. So if you see how the climate is impacting the marine environment, there are mainly two parameters. One is temperature and another one is ocean body slightly is alkaline. Okay. If it goes acidic, then we are not well. Yes. So you see, there is no much difference between the pH. It's not like a 7, 8 like that. 7 is neutral and 8 is alkaline. So 100 years back, it was good above 8, but by 2100 it become less than 8. So even that much of small difference in the pH matters. The organisms are mostly the phytoplankton, zooplankton, which are having silicon and calcium. All these are being affected because of this ocean acidification. Next slide, please. So, as I said, 93% of the energy coming from the solar radiation that is being absorbed by the oceans, and 44% it is being absorbed by the ice all over the polar regions and the mountain depths like Everest and all. And atmosphere actually absorbs 1%, and the land, the terrestrial land, is actually absorbing only 2% of the total solar energy. So this is the heat budget, which subsequently affect all the, or which gives a conducive environment. See, supposing we are talking about climate change and these greenhouse gases and all, if that shield is not there, or that carbon dioxide, if it is less, or it goes negative, if it is becoming too less, what will happen? Global chilling will take place. Now it is stabilizing. Because of the industrialization in the past 1 century, the carbon dioxide and other gases is going up and it making the imbalance. Otherwise, if it happens negative also, global chilling will take place. So actually, in the past, if you see, take the history and see, ice ages were there. Many ice ages were there. In geological time, if you see, millions of years back, ice ages were there. So it was happening and no human being that time. But what happens now, we are being affected because of the man-made problem of climate change. Next. So how the extreme weather conditions, like I said, El Nino and La Nina, which is warming and cooling of the world oceans in the South Pacific, which affect all the environment, particularly in the marine environment. From the warmer areas, the number of organisms migrate towards the conducive environment or colder regions, and the species migration it is also there. And it will happen in reverse is cooling is taking place, but now it is warming only. So because of that, distribution of zonation of fishes, each and every organism or plant, it's having its own zonation based on the physical chemical parameters of that area. Okay, if that is changed, then they have to move. Whatever the fish they can move, they will move out. The sedentary organisms, the organisms which are being attached, they cannot move within the physiological limit. They will stand. Beyond that, they will die. That is the situation. And increase in salinity in the near surface waters in hotter area. What happens due to the increase in temperature in tropical warmer areas or hotter areas? Because of more of evaporation, salinity increases. And the opposite is happening in the polar regions. Because melting of ice becomes more, and dilution takes place, and the seas which are nearer to polar regions, they become diluted, means less salinity. Here, more higher salinity, and there, because the recruitment, the baby fishes that after growing, they go to the marine environment, and then only we get it as a commercial fish yield. When this is gone, and that will be also gone. So directly it is related. Likewise, there is a complex commensalism between the organisms in the coral areas. Coral areas, lot of animal association are there. Okay, and coming to the sea level rise, because of, I need not explain what is sea level rise. You people are already knowledgeable. So the sea level rise, if you see in the past during uh, 1901 to 1990, it was 1.5 mm per year. Okay. Then it accelerated to 3.6 mm per year during 2005 to 2015. See, I am talking about the recent past few decades. Okay. So, and it rose to 4.62 mm during 2013 to 2022. So that is the situation. Now you can say, consider that it's about 4.6 mm per year the sea level rise is taking place. So it is projected, it is calculated that it may go up to 1 meter by the year 2000. 1 meter per year means it is dangerous. Okay. So next. So this I told about the water currents, the horizontal water currents. You have vertical water currents also in the sea. Do you know what is that? Upwelling, downwelling. Upwelling, downwelling, that causes the water exchange from the bottom to the top. That is benefit for the nutrition, nutrient, this thing, bring up the nutrients to the surface so that phytoplankton population is being good, zooplankton, fish reproduction like change. So as I already told about this, so these are all the arteries and veins of the globe, and the waste product as well as oxygen, nutrients, temperature, everything is being distributed or circulated all over the globe. That is making a buffering effect on the health of the oceans and the health of the terrestrial environment also. Next. So, like some artist has made the ocean as a heart. Just artistic is also good, but it's not, I think, scientific. Next. So, major ocean current systems, these currents also now in danger. The water currents, they are also in danger due to climate change. This is a news. Of late only, I have gone through this. I included it in my slides. So, major ocean current systems may also collapse as 2025, next year. And the chances are 98% certainty. See, there is a current called as Atlantic Meridional Overturning Circulation. There is a current, I think it is in the Atlantic Ocean, mid-Atlantic Ocean. So that has gone now, or has been weakening as the Earth continues to warm. So despite this, the intergovernmental IPCC has provisionally stated that the complete shutdown of the current will happen within this century. But a new study by a group of researchers from the Copenhagen, they have said that it will happen by the year 2025. In some literature, I saw it is 2025 to 2065. So whatever it is, from next year, it may start happening. Just like this. So this is the current. Using advanced statistical tools and ocean temperature data, you must be knowing very well sea surface temperature, how it is being used and all. So from the past 150 years, the researchers they have calculated and they have found that the thermohaline circulation of this particular current will collapse. It's 95% of certainty. It is not 50-50. 95% of certainty between 2025 to 2095. So that danger is there. This is the only information I got, that the climate change is going to affect the surface water, which sea currents also, horizontal currents also. Next. So this is already happening in the Arctic and the Antarctic region. So all the glaciers are, first it starts the melting of the surface ice, then it becomes a funnel-like structure. Okay. Melt water flows into a large molding. That funnel-like structure is called as molding, and then quickly all the melting will take place. It will take more time till that funnel-like structure forms. Once the funnel-like structure is formed, then melting goes on quickly. This has been reported by BBC News quite some years back. Next. So this is, you might have already seen this set of pictures. What in a few decades back, the ice in the polar regions, black and white photography. Now you see the same area, same place. Beautifully, you can see the mountains, but the actual beauty has gone. The ice is gone. One slide I'll show you last. Our globe will become totally iceless. Next. So already there is an alley. Alley means road. In Canada, there is an alley in which 150-foot icebergs pass through iceberg alley. And where iceberg alley in the Western. It will be frequently the ice which are melting from the North Pole that goes via the, into the sea. Alley near Maryland, Newfoundland, Canada. You see how big that iceberg is. How big? It's many, many times bigger than any other ship. Okay. Next slide. So, another shocking news is these ice, what it is being getting melted in the polar regions, they have fossil pathogens, fossilized pathogens. You might have studied even in schools about the woolly mammoth. Even now, mammoth, Yanamari Prasad, woolly mammoth. Okay. That was there, that is a extinct one. But we are getting its body frozen, well preserved in the polar regions. Okay. We have already got this in the American Museum. So what I mean is, pathogens also for centuries they are there. For example, one you see anthrax spores that emerged from thawing of permafrost. Permafrost means the ice permanently frozen and like rock. It is there. Take the core. What you get the ice core from the bottom. That is the permafrost. Okay. It is not building and melting. It's not. It is always there. So in Siberia, what they got that core, and when they tested, there were pathogens, and they were accidentally released into the terrestrial environment, and people and reindeer so they were affected because of that viral disease, anthrax spores. Next. So even today in the meeting, we were talking that shoreline changes are taking place. Actually, we were not having time. That time I would have added that sea level rise is another problem that is going to add up. Marina Beach after 100 years, it may be very nearer to our Marina Beach road. There won't be a stretch of Marina Beach, so that may happen if something. It is not already somewhere they have marked. Okay, in 2030, sea will be here. In 2050, sea will be here. Means sea level rise and intrusion of sea into the land areas. Already our projections they have made and vulnerability maps have been brought. For India also vulnerability map is already available. You can see the whole of the coastal area they have gone. Okay, next. From NASA, somebody reported, not NASA. Some other organizations they took the data of NASA and they have made modulations and they predicted people sitting in America, they are bothered about a place like Chennai, that all our Perambur, Villakam, that areas, whatever the low lake, wherever the creek is going. So the Cove River adjoining, wherever the flooding was there. So those things will go if the sea level rise increases and the sea intrudes into the area. So this is the projection that after some years it will happen, or it is slowly happening. And the problem and the tragedy of the sad thing is what we expected that will happen 50 years after that, it is happening in 30 years. So what we thought, the things are happening in a more faster way than what we calculated or estimated. Next. So தமிழகத்தில் கடல் அரிப்பு, தமிழ்நாடு மோசமாக பாதிக்கப்பட்ட ஒன்றாக உள்ளது. இது மாதிரி the news is coming, people are not bothered. Next. And mangroves, as I told, mangroves, they are the natural shield in the time of cyclone or tsunami. These mangroves, they have protected the coastal areas. I myself, with my own eyes, I have visited Nagapattinam area when 2004 tsunami hit was there. Even that time, dead bodies were taken in trucks and all, and the whole town was smelling there, bleaching powder and all. And it was like a full burial ground. That stink was there, smell was there. I visited some coastal Nagapattinam and adjoining areas. Wherever the mangroves were there no destruction at all. Only that mangrove and whatever the shrimp farms were there, they got destructed, and all the villages, no single casualty, no death at all. But whereas just the adjacent villages where it was barren, no mangroves, nothing, there many people died. So it is how mangrove is not only that it is acting as nursery and all, but it's also protecting us in the case of natural disaster like a cyclone and tsunami. Next. And mangroves are a real carbon sinks. So they absorb 4 times carbon more than the terrestrial forests. In that way also mangroves, they are to be protected. Next. When talking about the human population, 1/3 of the human population all over the world, it is all nearer to the oceans and water. Even in the inland areas, if you see from flight, otherwise also, if you see wherever the human habitation is there, it is there is a river or lake or something like that. Because water is essential for human beings and cattle and everything. So that is how the human settlement naturally it is more towards the water fronts, including the seas. So 33.5% of the world population live within the 100 vertical meters of the sea. This is not 100 horizontal, 100 vertical meters. So to some extent, inland people are, because they must have easy reach to the sea. Okay, if not daily, they should be able to have some shorter distance. And globally, about 600 million people are living within 10 meters of land elevation. Within 10 meters, 600 million people are living from the mean sea level. So this graph also shows the population density. Green and white and all, totally less populated, and that orange and all, it shows the highly populated areas. So it is directly related to the fact that the seas are acting as a means ecosystem services are very important for the human settlement. Next. Harmful algal blooms. The temperature increase. This is another problem in the ocean and in the freshwater aquatic systems also. When the temperature increases, what happens? The algal blooms are taking place. The population of the algae, they start increasing, and once they go beyond a certain limit, the population becomes toxic. Anoxic condition it takes place. and the algae themselves are releasing toxins into the water, and the animals consume them, and they are being affected. And this type of harmful algal blooms, irrespective of the poor country or rich country, it is happening everywhere. If you see, Google and see every place, every 5 years or once in 5 years or so, the incidents will be taking place because it's a combination. Temperature increase. Suppose you it is a landlocked area and there is no much aeration, water, wind circulation, and all, the temperature will increase. Okay, so that is how when high nutrients and temperature takes place. When there is no water movement and heat is there, it will start deterioration and all the bad things will happen. Next. So harmful algal blooms, how they are affecting the marine organisms? They are blocking the gills of the fishes. Toxins are released from the algae, and the toxins which are released from the algae through trophic levels, through food chain, it reaches the human beings also. Wherever in the coastal areas where the harmful algal blooms are taking place, there are some casualties because of the food poisoning from the algae. We are not eating algae, but countries like Korea, Japan, and all, many countries they eat algae. They do cooking and all. Still, food poisoning is taking place accidentally, and oxygen depletion takes place because of the dead zones. Dead zones are being formed. Prevent light penetration because of the thick mat-like algal formation in the surface. Just below that, you don't get already aphotic, dysphotic, aphotic. Right? So only for some distance the light is there. After that, it is totally dark in the sea. But whatever in the lighted area is happening, that is the autotrophic food production through this thing, chlorophyll and all. Okay. So when light is being prevented, that affects the photosynthesis and HPS formation. This is the extreme stage. Hydrogen sulfide formation is taking place when it is too much of denser. If this is happening, it ends up in the HPS formation. That is the most dangerous situation. And climate change in the three ways it is affecting. One is heat and acidity. Okay, so oxygen. So less oxygen, heat, and acidity. So these three are the major happenings due to climate change that are being affecting in the other levels like sea level rise, oral bleaching, toxic algae, just what I said. Habitat it is being destructed, acidification, and fisheries, of course. Next. So, oceans are having a lot of organisms. Whatever the largest organisms in the world available, they are only in the seas. Like blue whale, shark, all these. Okay. Whales, blue whale, sperm whale. These two are the big ones. And you see octopus also 35 big giant Pacific octopus, Japanese spider crab. 121 or 12?
12.1. So.
76 is the sperm whale. Even squid, giant squid. And so many big organisms they are giving sponges, giant sponges and giant mollusks they are there. It's like a chair of this size. One can sit when it is open. Right? In the Philippines it is there. So that type of organisms we are gifted only in the seas. It's not in the terrestrial or freshwater areas. But when these pollutions and all other activities are affecting all these organisms, they are being affected. There is a census how much in a year due to plastic pollution, how much seabirds are killed or affected. Sea turtle, almost 100,000 sea turtle they have assumed that in one or other way they are taking the plastic in their lifetime, and 300,000 dolphins every year they die because of the ghost nets. You must be knowing what is ghost nets, and the net which are being thrown into the water, which are suspended and they are moving here and there. In that they get these dolphins are getting entangled and they die. Okay, next. Okay, and now let us narrow down to fisheries. No, what time? Google Meet time. No. Okay. Okay, I'll finish. I'll finish. I'll finish in something. So next slide, please. So fisheries, it is being affected due to climate change, mainly the temperature. So this temperature is interferes with the physiology of the organisms and their metabolism, growth rate, reproduction, and tolerance to disease and toxins. These are the major aspects that affects the climate change. Temperature increase affects the organisms. Okay. So the climate change is already impacting the world's oceans and will have serious consequences for the hundreds of millions of people who depend upon the fishing for their livelihood. So when the fisheries is affected, the people who are depending upon the fisheries, it's not only the fishermen. There are so many other sectors related to fisheries. Those who are catching the fish, they are fishers. Okay. Once it is being landed, trading takes place. Okay, in the trade, domestic market is there, domestic trade is there, international export trade is there, and from there it goes to processing centers. So how many people are working out there? From there it goes to the interior areas or being exported. So the whole, everybody is being affected if the fisheries affected. It has happened. Next. So this is how the production of world fisheries and aquaculture that has happened from the year 1950, more than half century. It started increasing. The one what you see is the blue is the capture fisheries in marine water and inland water. This one is a marine water. This one is a freshwater. So slowly there was a rise, but it stagnated. It never gone up. Because it means the natural populations in the sea, fish population in the sea, they have started dwindling. Because of that, the fish catch stagnated. After some years, it may go down, started going down. There comes the aquaculture. Now the fish being produced. Fish means all the kingfish, shellfish, seaweeds, everything from commercial fishery point of view, everything is fish. So what happens in the 1980s and all, afterwards, all over the world, the aquaculture production has started increasing. Earlier it may be 80 to 20. 80% the wild catch and 20% the aquaculture production. But now it is 50-50. Okay, after some time, due climate change and all of the overfishing and human intervention, pollution, everything is happening. The natural population in the sea will keep dwindling. And aquaculture is the only helping hand. We have to do aquaculture in the inland ponds, okay, or in the pens in control, right? Then we have to go for high-tech cage culture, all this. So a day may come that you will not find fish in the sea and nobody will, no fisherman. Okay, only fish aquaculture will be there. A day may come. Okay, next. So these are all the fishing zones divided, marked by the Food and Agriculture Organization. So it is for census purpose. When we in conference and any other international meetings, wherever the discussions are being made, so they talk about the people from Russia means they will mention that name. Okay, I think it is 51 for us. So it is 13 for India. Okay, so different names are there. If you go to FAO site and you can find what is the fishing zones. Fishing zones, FAO, you will find all this. So, climate change, how it affects the shelled organism, shellfish. Okay, since they have calcium on its body, the ocean acidification affects the organisms like the shrimps, oysters, corals, because their calcification is being affected because of the acidity, right? And zooplankton is in the food chain. Primary producer is the phytoplankton, right? And primary consumer is zooplankton. Okay. And secondary consumer is small fishes. So these zooplankton population, if they are affected because their body is with more of calcium, because of acidification is that zooplankton, if they are affected, there takes place a break in the food chain. Okay, crack or break in the food chain. So totally, even the autotrophs produce enough energy of the food that will not reach the top of the pyramid. Okay, so this is how it is very important. In climate change, it's not directly affecting; it is indirectly affecting the whole of the food making process. Finally, we are the benefiter. Okay, so we will be problem. Next. And this is a case study in Africa, I think. Yeah, Kenya, United Republic of Tanzania, Madagascar, Seychelles, Mauritius, Eastern African countries, vulnerability has been studied. Okay, in that less vulnerable and more vulnerable. If you coral bleaching, it is because of the coral bleaching. Wherever the coral bleaching is taking place, their livelihood is finished. It's not just only fishing. The coral supports many of the land industry and like that many industries in countries, poor countries like Africa. There is no other income for them. They are totally depending on that. In such case, the livelihood is totally affected. So they have made this type of scientific graph: less vulnerable, more vulnerable. Small one is low exposure, medium exposure, high exposure. Okay, small means low exposure. They are safe. Large ones, high exposure. Which countries? So Kenya and all, they are having more exposure as I can make out. Okay, so they are being affected much. Next. This is the distribution of dead zones where there is no oxygen at all in the sea. Oxygen coastal sites where anthropogenic human activities, nutrient release into the water that causes oxygen depletion, red dots. As well as ocean oxygen minimum zones at 300 meters depth. See, scientists they are making studies where what is the oxygen level at the surface and in the inside the sea also. At 300 meters depth, the oxygen minimum zones starts. Taking the samples periodically and finding out how much oxygen is there, and it is being mapped. And what you get is this type of dead zones. So this is again danger zone. It's a human activity. May not be directly related to climate change. It is the human activity. Next. So this is the photo how it's being affected. The climate change, temperature increase affect the zooplankton and the small fishes and the big fishes and the fisheries assets. So body mass, as the body mass increases, the decrease in number it takes place. Next. And this is the spatial disturbance of climate change. Because of the temperature, increase in temperature, what happened in the Somali coast, there was, I think, tuna population. Tuna. Major spatial shift of the tuna fishing fleets. Already what the very rich tuna schools were there, fisheries were there. they have started moving towards the colder region because of the increase of temperature in this particular area. This is one small study. It may be happening in many places all over the world. So what happened? The tuna, they have started moving from this place to another place. Probably this place is better temperature is relatively cooler, so they might have moved. And because of that, what had happened? So whatever the fishery, the infrastructure, the economy, depending upon this tuna, see, countries like Lakshadweep and all is totally tuna. 90% of the economy maybe tourism and tuna fishery. Okay, if you go to houses or hotels, tuna soups, tuna burial, all the 3 times they take tuna. Because that is the abundance, in abundance it is available and it is good. Okay, but we cannot all the 3 times can we take fish from morning, lunch and dinner, we cannot be able to take. But the people over there, so their livelihood as well as their own nutrition is being affected because of this. Next. So this is in summary. I have included both freshwater, river, and all this. So temperature, all parameters: temperature, rainfall, extreme events, flood and droughts, wind pattern, evaporation, river flow, lake level, sea level rise, salinity, water intrusion, saline water intrusion. Today morning we were discussing about the saline water intrusion into the freshwater aquifers in the coastal area. In Muttukadu, in the year 2000, we were getting very good water, drinking water. We used to drink from Muttukadu. Our lab is there. We used to, evening when we are returning, all our staff members, we fill their water bottle with water from Muttukadu to Chennai city. Because in Chennai city, we don't get good water. But now it is the opposite. All ECS areas, groundwater is salty. Okay, now it has become totally within this 23 years. What I am telling, 23 years, 24 hours. So this is about groundwater aquifer. It is being affected by the saltwater intrusion. When the sea level rise is more, intrusion will also be more. Okay. Even that will affect the agricultural lands. Slowly, agricultural lands, you will not get fresh water. You will get salt water. Only salt tolerant paddy fields, 8 ppm, 10 ppm parts per thousand. Okay. Some varieties they can withstand, like Pokali in Kerala. Okay. So only that type of salt. In the MS Research Foundation, they have discussed that salt tolerant paddy. Only that type of paddy will be grown. So, in this event of climate change in the future, we are compelled to develop climate resilient varieties of agricultural crops, and we are also compelled to develop climate resilient varieties of fish for aquaculture. Okay. They should be able to tolerate high temperature. They should be resistant more for diseases. They should be able to be more tolerant for high salinity. Okay, so that is the situation which is going to happen if the business as such is going on. Okay, so all this it will take much time to explain. It's there in Google. You can see. And India, how much, whatever the economic development, whatever the economic activity is going on. Now, what I am talking, I am emitting so much of carbon dioxide in one or other day. Okay, our body, gap order, methane burning. So, like that, we are adding the greenhouse gases, methane, carbon dioxide, methane, nitrous oxide, CFCs, and some more gases. Okay, naturally from animals and all, here we are tilling. Tilling, when you do that, the bacteria they produce nitrous oxide. So conventional tilling is now modified. ரொம்பவும் அதை அழுத்தி ஓட்டாம லேசா பண்றதான். அதை வந்து modified tilling agriculture சொல்றாங்க. That is a climate resilient technology. Likewise, now we are developing climate resilient processes, climate resilient technologies, and climate resilient varieties of organisms that will be more and more developed. So fishing activities, why I am telling every activity is having its own impact and carbon dioxide is being produced. Methane, everything is being produced. So in fishing activities, when compared to any other thing, it is less. And one publication says that in India, the carbon dioxide emission it is less when compared to the global average of 30%. Sorry, 2 tons. Ours is 1.3 tons. This is from Central Marine Fisheries Research Institute. They have made a study. So it is a bit happy news that our fishery industry is not uh, polluting, means not releasing much of carbon dioxide into the atmosphere. But it is being released into the atmosphere all over the world. Next. So in the case of aquaculture, the impact of climate change is the same on the organisms, whether they are in the open sea water or in captivity, in cages or pens. So climate-driven changes in temperature, precipitation, that is rain, ocean acidification, hypoxia, that is oxygen sea level rise. So these are all the things which directly affect the organisms through their physiology. Okay. And of course, water and air currents, wind speed, waves, and all, they have direct impact on the physical impact on the structure. Even in fishing also, say in cyclone, the boats may be get affected, net may be get torn. But in aquaculture, coastal aquaculture particularly, when cyclone comes, totally everything is damaged. Capital investment itself is gone. It is not running investment. Okay, whole thing from scratch. Again, you have to build everything. It is very expensive. Losses high. Next. So, extreme weather conditions. That's what I am telling. Storms and flooding. In the case of coastal waters, mostly it is cyclonic storms. Once in a while, tsunami, and in freshwater flooding. Freshwater flooding. Video so that type of flooding will also affect. So in climate change, the incidence of extreme events are getting more. Intensity of the extreme events are also getting more. Okay. Fish and shellfish subject to different stress, physiological affected growth, development, disease, infection. So whatever I told for the organisms in the open water, that is also there. So just now I said that we have to develop selective breeding, through selective breeding. How it is that what we found GMO, genetically modified organism. It's dangerous. It is not to be encouraged. At least government of India is not encouraging GMO because the future effects may be different. When you modify the gene, definitely it will end up in some problem. So selective breeding is a good alternative. Selective breeding, for example, I want a prawn of good color, good taste, okay, and good size. What I will do, I will collect the same prawns from different areas. I will select the good color one. I will select the good size one. I will collect the good shape, taste. Okay, all good characters I will put together and I will breed them. Okay, after 2 generations, 3 generations, 5 generations, I will get the progeny. In that, genetic plays the role. Okay, in that some you will get with all the good color, good taste, and good size. So this is called as selective breeding. It is there in animals also, cattle, everything they are doing it in agriculture, cattle, animal husbandry, and aquaculture also. So we will have to do for the selective breeding for more robust size. Robust means they should be strong for temperature and salinity increase. Okay, disease resistance and anticipated means all these are being anticipated and already initiated. In some Western countries, they started probably With the selective breeding, I think they are doing also with the genetic modification. But in India, supposing if any of you are going for research in this type of work, don't go for GMOs. Don't touch them. These things. Genetics only selective breeding you can do. National institutes also we are permitted only to do the selective breeding and not GMO. Okay, all physical damages I already told. Next. Whale pump. See, there are some natural carbon capturing taking place in the sea. Whales. These whales are, one whale is equal to thousands of trees from climate change point of view in carbon this thing, catching, carbon catching. Okay, how? I'll tell you. The whales, they go to the bottom and have their food. Okay, they can be there under the sea for many hours, and for to take the oxygen, they come to the top. At that time, either habit, they go for number 2, or release the fecal matters. Right? Those fecal matters are highly nutritious. That dissolves and release the nutrition in the surface water. So this nutrition is immediately available to the phytoplankton, and the phytoplankton protection increases. Okay, then phytoplankton this thing is process is going on. What happens? It automatically it takes the carbon dioxide. Okay, for photosynthesis it takes carbon dioxide. This is how carbon dioxide, whatever you say, 25% or 40% or 50% of global oxygen carbon dioxide protection is being absorbed by sea. It is not the water, it is the phytoplankton. They do it. They do it normally, and in the case, in such cases also, it is many times more. Whale pump, reptile pump, there are so many things. You can Google and study. Even I am writing so many articles. Every month I am writing. This month also I have written 2 articles on ocean currents. அவங்க எப்படி செஞ்சிருப்பாங்கன்னு சொல்லி பிபிசி போன கான்டாக்ட் பண்ண அவங்களும் சொன்னேன், அதுவும் வந்துருக்குது. ஸோ தெர் ஆர் சோ மெனி currents that affect. ஸோ இது வேற வேலை இல்லை. வேல் பம்ப் மாதிரி நிறைய பம்ப்ஸ் இருக்கு, ரெப்டைல் பம்ப்ஸ் இருக்கு, நிறைய படிப்பு தெரியுது. ஸோ வாட் ஐ மீன் டு சே இஸ் natural sequestration of carbon is also taking place in the sea, and we should be tackling to oceans for having such organisms that are capturing the carbon. Next. The South jellyfishes. They are burying 700 million metric tons of carbon to the deep sea globally each year, equal to emissions from more than 150 million cars. Jellyfish சொல்றோம்ல, that is a menace problem. நிறைய இடத்துல வந்து பிளாக் பண்ணிடும், ஆக்சிஜன் கிடைக்காம போயிடும், சர்ஃபேஸ்ல மீன்லாம் செத்து போயிடும். பிகாஸ் ஆஃப் திஸ் இன்னும் நிறைய சொறி இறங்கணும்னா நம்ம மேல பட்டு சொரின்னு சொல்றாங்க. அந்த சின்ன சின்ன நீடு அது மாதிரி. ஆனா ஜாப்பனீஸ் சைனீஸும் வந்து ஜெல்லிஃபிஷை ட்ரை பண்ணி டீஹைட்ரேட் பண்ணி அப்பளம் மாதிரி அதை பண்ணி அவங்க தேர் ஈட்டிங். தட் இஸ் குட் திங். நம்ம ஏன் அது பழகன்னு தெரியல. ஸோ ஜெல்லிஃபிஷை மட்டுமே ஒரு லெக்சர் நான் எடுக்கலாம் போல இருக்கு. Later you can see how they are capturing the carbon. Next. So what can be done? We must admit that climate change is everyone's problem. No agency, no government, no scientist can fix it. We are all responsible, and we are all together. We have to mitigate. Okay, mitigation and adaptation to the climate change. How we can mitigate? Only by reducing the production of greenhouse gases. Next slide, please. So reduce the carbon emissions, tap alternative energy sources, carbon capturing and sequestration. இப்போ நிறைய பனல் மாதிரி மாடர்னா பனல் மாதிரி இருக்கும். அது வந்து ஏர்ல இருந்து கார்பனை பிரிச்சு அதை கொண்டு போய் ராக் மாதிரி பண்ணி பண்ணலாம். என்னமோ டெக்னிக்ஸ் வந்துருக்கு. They are expensive. But whale pumping is natural. அதனால conserve whale to capture more carbon. Mitigation, அவ்வளவுதான். Adaptation. So climate resilience techniques, climate resilience crops, special varieties, இதெல்லாம் develop பண்ணி we have to adapt ourselves. Whatever that is happening beyond our capacity. Okay. Next. So if we don't do it in the coastal areas, we have conducted conference like this under the sea. Okay, under the buildings. At that time, whatever you discuss, nothing can be done. It has gone beyond. Okay. Next. This is the one I told. 4.4 million years ago. Full earth was fire age. 750 million years ago, ice age. Full ice age. இன்னைக்கு ஐஸ் பாசி அழகான blue color எல்லாமே. So after 100 years or later, totally there is no ice. That is what is assumed. If the things are happening after 100 years, there will not be ice in the mountains, Arctic regions, Antarctic regions. So you can imagine how the life will be. Next. So, Greta Thunberg, the girl, what she did, Greta Thunberg, the girl, they are not there. The girl, Greta Thunberg, she at the climate change conference, she went and she sat alone in the road, protecting the conference. What she said to them, what is the use of you people coming and talking? We have to do action because future is ours. Future is ours. These people will talk and go. Right? What will happen to the earth which belongs to us in the next 100 years or 50 years? That has started a movement and all over the globe, children, they are very much aware. Grown-up children, you should also be aware of this. And you should try to contribute yourself, whatever you can do. As an individual, whatever we can do, we have to do it, right? By using bicycle, right? By using less carbon emitting vehicles. Electric scooter, but on the electricity, what you are getting is from burning the coal, then it is not climate resilience. So you should get the electricity from wind power, tidal power, wave power, solar power. Then it is a clean energy. Okay. Otherwise, using the electric vehicle from the coal burning electricity, it is not clean energy. But so okay. 1 minute. There is. So awareness creation, climate action, pro-climate policies and governance. Apart from technical things, what we have to do. Awareness, this is a must. All should know, each and every individual should know what is climate change, what we have to do, what we should not do. And climate action means from government level, from individual level, whatever we can do, we have to do. And more importantly, the governments have already taken, it's going on. Even in Tamil Nadu government, I think it is the best government in state government, in all the Indian governments which are pro-climate. There are many projects which are being planned and money is being allotted for climate actions. And alternative is this thing, new lab-grown bacteria consume carbon dioxide in Israel. Germany, bacteria that eats only the carbon. So this type of inventions will definitely help. Whatever the carbon emission goes out, that can be somehow brought down. Okay. Carbon what it is there, it is being buried and then it comes out through nutrient cycle and all. Only problem is, you see that there is no much carbon density in the atmosphere. That is our concern. You pull them and you bury them into the sea and land. Whatever we have to do, that is the thing we have to do. Then climate will be fine. Okay. Next. So one Darwin's report, he might have not meant climate change, but we can assume that it is climate change. What he told, it's not the strongest species that ultimately survives, nor the most intelligent. புத்தி மூளை ஸ்ட்ராங்கா இருந்தோ இல்ல உடம்பு ஸ்ட்ராங்கா இருந்தோ அதெல்லாம் ஒண்ணு வேலைக்காது. But the species which is most able to respond to change in the environment, climate. So, environment என்ன சேஞ்ச் ஆகுதோ அதுக்கேற்ற மாதிரி அதை அடாப்ட் பண்ணி வாட முடியாது மட்டும்தான் உழைக்கும். அதோட ப்ராஜெக்ட் தான் வரும். அந்த ஸ்பீசிஸ் தான் கட்டிங் ஆகும். மீதி ஸ்பீசிஸ் தான் பயங்கர இன்டெலிஜென்டா இருந்தாலும் சரி, ஸ்ட்ராங்கா இருந்தாலும் சரி. தேங்க்யூ. தண்ணி இல்லைன்னா மீன் இப்படிதான் வெட்டி கட்டி போக வேண்டியது. Next. So we have oceans and forests. Terrestrial, land states here, symbolic. We have to take care of our vegetation, trees, and we have to also take care of our oceans.
Thank you, sir, for enlightening us with immense knowledge about climate change, ocean and fisheries. Moving on to the next session, I am delighted to welcome and thank Dr. R. Nagalakshmi ma'am, Associate Professor, Department of Civil Engineering, SRM IST, for accepting the invite to present the lecture today. Dr. R. Nagalakshmi is working as Associate Professor in the Department of Civil Engineering, SRM Institutes of Science and Technology, Kattankulathur. She has completed MSc Oceanography and Coastal Area Studies in Alagappa University and MTech Coastal Management in IOM Anna University. She has completed her PhD in Anna University under ISRO-SAT's Space Application Center sponsored project topic on integrated coastal zone management and ecological evaluation of radar and coast using remote sensing and GIS. Her research interests include air-sea interaction, climate dynamics, oceanography, climate variability and change, marine ecosystems. I now request Dr. R. Nagalakshmi ma'am to deliver her lecture.
Last class, that is the first of all, I would like to thank our director ma'am to inviting me in this occasion, as well as I thanks to sir because of he has also invited me for another program. So through that way I came here. So that is the one thing. Very happy to see you all. I'm not taking much of time because of I understand your patience. Okay, already sir has given much of the information to you about our ocean. Okay, we are focusing, that is one of the project we are handling, that is MSMP project. Okay, that is the qualitative and quantitative assessments of marine litters and microplastic along east and west coast of India. So I am covering only his coast only now. Okay, so we all know our Indian coast is vast, stretch, that is the 7,516.6 kilometers. Okay, it may be a little bit varying according to those who are mapping. Okay, mapping of the ocean coastal. Okay, so it has covers that is the 9 coastal states as well as the 4 Indian territories. Okay, so these all the coasts we are covering for to finding the that is the microplastics. How much of microplastics are there? Okay, so based on that we are making the policy. Okay, so how to we reduce using of plastics. So this is sponsored by, that is MOES, Ministry of Expenses. They are providing us funds for doing this work. Okay. So I'm directly going for the topic because of this time we are having. Plastics, based on their size, we are classifying nanoplastics, microplastics, mesoplastics, and macroplastics. Okay, so based on this is the NOAA classifications we are having. Okay, so that is the nanoplastics, very minute size. Okay, and microplastic is little bigger than that, but we cannot see that microplastics also. And mesoplastic we can see. We can able to see the mesoplastic as a macroplastic that is a greater than 25 mm size. Okay, so microplastic in between that is a 0.001 mm to 5 mm size. Okay, so this is we cannot see in our naked eyes. So we can use our microscope and FDR analysis. We can find out what are the characteristics of the microplastics in chemically, and the microscope is helps to find out the what is the shape, size, and colors. Okay, so these results we can get. So this is another, that is we are focusing only the microplastics. Okay, microplastics we are having two types. That is the primary microplastics and the secondary microplastics. Primary microplastics are, that is the directly they can manufacturing and applicable for various uses. For example, gel paste. Okay, and facial sheets. Gel paste you are seeing some of the ribbon like a little bit. Okay, so that are the microplastics. Okay, so that is the essentially we are producing for applications only. Okay, that is a microplastic. Secondary microplastic, that is a primary microplastic. Secondary microplastics are that is the larger plastics which is fragmented and which becoming minute size. Then we are considering as the secondary microplastics. Okay, so these are the two types we are having. And this is the based on the classification, chemical composition. Okay, we are having different plastic types. We are finding these are some of the plastics in our Indian coast. So these are the polyethylene, polypropylene, polystyrene. So many we are having. Okay, based on the chemical composition, we are having the classification and the specific gravity. Why we need to find out the specific gravity? It may be float or the deposit in the sediment. So based on the specific gravity, we can find out. Okay, so that's why we have mentioned that. There is a specific gravity, so some of them floating and some of them sinking to the environment. So this is the other project objectives. Okay, so that is the field sampling, collection, qualitative and quantitative assessments of marine litters and microplastics in some of the major and minor river and nearshore locations along east and west coast of India. That is the main. And another one is to assess the distribution of marine litters and microplastics in ecological sensitive areas such as mangroves, coastal lagoons, and estuary ecosystems. Apart from that, and we are mapping the using the GIS software. We are mapping the macro, that is the litters. Okay, we cannot mapping the microplastics as litters. We can mapping with the help of the drones. Okay, and GIS software. And another one is the cost-effective tools. Any innovative ideas, innovative instruments can be found. That is the one of the objectives we are having. Another one is giving the awareness to the public and the stakeholders. So this is one of the tools we adopted for that is for taking part in the ocean like the extent distance of India, the sample selection for the sample selection in the ocean. Okay, and in the coastal region, we are taking the small ships and we are taking the samples. So this is the methodology we adopted for that. That is the first one is the sample collection. We are using number of instruments for the sample selection as well as the sample processing after the sample selection. We are bringing the samples to the laboratory and we are doing to that is the segregation of the microplastic from the samples. Water samples are the sediment samples. So that is the sample processing. So sample processing we are having the density rotation, weight peroxide, that is the organic digestion, next one is the vacuum filtration. We are doing that under the sample processing method. And the qualitative analysis with the help of the FDR and the microscope we are These are the field equipments. This is the metanet and the digital flow meter. Metanet, which is used to that is collect the water sample, which is surface water sample. So this is the collector we are having. That is the float which used to float in the water column. And this flow meter which is used to find out how much of liters of water enter into that particular tank. Okay, we are taking the 10 liter. That is the 10 minutes time to tow the net. Okay, so that time, how much of water is entered into that net, that is calculated by the flow meter. Because the quantification is very important to find out how much of water is entering into the flow meter. That's why we have to take that information measurement. Okay. Next one is the offshore segment sampling. We are using the volume graph. Okay, that is the bucket type. okay, which enter into the bottom, it flows. Okay, then it will collect the sample. Okay, that way we are collecting the sample. We have collected the sample. In the East Coast, we have completed that is Andhra Pradesh, Odisha, and part of the West Bengal, and Tamil Nadu, part of the Tamil Nadu also. We have collected the samples and analyzed. So this is the surfaces which is used to find out the turbidity level of the water. Okay, so this is the portable multi-parameter meter. So if you will use for that is we have used for this find out the pH, ORP, EDS, resistivity, salinity, temperature, EC, and dissolved oxygen, atmospheric pressure, and next one is the GPS we all know. We are writing.
Starting to change. Nice.
11 members.
In this page is
And I was doing
you are.
presentation is clear.
Sure. Okay.
So this is the underwater camera for the seagrass sample collection. We are using underwater camera. So these are basic things now laboratory equipments. Laboratory equipments glass distilled, that is the double distilled unit which is used for prepare the distilled water, and hot air oven sediment samples we tried with this below 50 degrees centigrade because of plastics. Sometimes it may be starts to melt. Okay, so we are maintaining that, and sometimes the colors will be changed. So for that we have to maintain 50 degrees centigrade during our analysis. Hot plate magnetic stirrers which is stimulating the process very fast. Okay, so for that we are using that, and vacuum filtration systems which is used to filter the that is the plastics after organic digestion. So that is one of the process we are having. During the processing, we will see that. Okay, so after that process, we have to filter the sample with the help of the filter paper. Okay, so this instrument is used to filter the microplastics. So filter paper we are keeping it here, this place. Filter paper we are keeping this place. Then we have to do the filtration. Okay, it takes some time. Okay, so this is the filter paper. That is the diameters we are using for some filter. And vacuum desiccator is for we do not take any risk for contamination. Okay, after filtering that microplastics, if air also having some of the plastics which is entering into the sheet. Okay, so for that we are drying with the help of this desiccator. Okay. So this is the digital stereo zoom microscope, so which is used to find out the microplastics characteristics, physical characteristics, shape, size, and colors. These are very important information where it generates. Okay, it's near the source, it's near from the source or away from the source. So that gives the information based on the colors, their shapes. Okay. So these are the sample collections. So during the sample collection, some of the photographs. Okay, so this one is so this is the trap. Okay, so this is the processing of that is the methanate. Okay, so methanate we are deploying there. Okay, so this is some of the photographs. And microplast has so that I will explain. This is the microplastic particle pump, which is for ocean. Okay, which is for ocean. The surface water sample selection we can do with the help of the metanet, but this is will be using to collect the sample in the deep water also. Okay, so for that we are using it as the mesh sizes 5,000 micron, 500 micron, and 200 micron, and 100 microns. Okay, so each one single deployment we can take different mesh size of the particles. So that is the one advantage we are having for the microplastic particle pump. It is applicable only in the ocean. So this is already I mentioned how we are handling the crop to take the sediments. So this is the beach sediment is another method, that is the quadrant method. Okay, quadrant method that is the this quadrant which has the 2 into 2 or 3 into 2 specific sizes we are having to collect the segment samples, how much of microplastic is present in that location. So which is received, which is done by sieve analysis. So which is as different sizes, 0.3 mm size, 1 mm size, and 5 mm size. So we see and we can identify how much of plastic in that chamber. That is the in that quadrant method we have taken. We have to take. And the core method, this is the deep sediments. Okay, in the coastal region, in the deep sediments, we are using this core method to find out some of the depth also, some of the microplastic enter. So how it is and how much it is there in the depth, deep also we can take with the help of the core method. So that is the procedure. Time is less, I am passing through that. Okay. Sample analysis, microplastics need to be isolated from the water and sediment sample in order to be characterized and quantified. Okay. So what are the process we are going to do means, which involves the wet sieving. This is the wet sieving second one. Wet sieving, chemical digestion, and density separation, vacuum filtration. So this is the entire methodology adapted for that. Okay, so first of all, we are using the sieve. What are the organic matters? So many organic matters are there. Some leaf, that is a macro size particles that we are removing from first through the sieve analysis. After that, for that is the organic matter digestion. The organic matter digestion. So we need not to take the organic matters for our analysis. So for that, we are digested that. After that, we are going for the density separation. So density separation, the plastics are float in the top. Okay, so that is the density separation. We are adding some of the chemicals. We have to do that. Okay, we will see what are the chemicals we are using there. Okay, after that, for after completion of the density separation, we are using for the vacuum filtration. We can filter the microplastic both in sediment and the water sample. The same one for the sediments. Sediments, what we have to use, one extra step is there, that is the dry. Okay, the oven, we are using the oven to dry the sediments. So this is the wet sieving analysis. So sediment drying and the chemical digestion, we are having the acid digestion, alkaline digestion, oxidation agency. Okay. So out of these, we are using the hydrogen peroxide only because of its acid we are using. So the color may be changed. Okay, some chemical reaction will be happening. So we avoid that. Okay, another alkali also the same problem. Some of the color fade will be happening. So we have to that we have selected for activating agent that is the hydrogen peroxide. So hydrogen peroxide we are adding for the chemical dilution. This is the procedure. Okay, so peroxide activation. This we are doing 20 ml of 30. That is the 30% of hydrogen peroxide solution is added to sample and is left for 24 hours. Okay, this may be varying. Yeah, because of based on the organic matter presence. Okay, that may be high polluted region. We are collecting samples. It takes 1 week also. It's not single day process. It takes a number of days to digest. Okay. So this is the common procedure. 24 hours we are left for the digestion is the common procedure. Based on that is the pollutant, it will be varying. Okay, so this is the common. And the samples can also be heated less than 50 degrees centigrade using hot plate to foster as a digestion process. We are that is the catalyzing the process. Okay, this process is repeated till no organic matter is visible in the samples. That is a very important. So density separation, so after the digestion, we have to do the density separation. So density separation is performed to isolate the plastic particles from the rest of the samples through flotation. Okay, for this, wet peroxide solution is added to liquid solution of higher density, that is the zinc chloride and the sodium chloride. Okay, so solutions is used for this purpose. For the density separation, we are using the zinc chloride and the sodium chloride. So that is the percentage, how much the percentage, that is the specific gravity is mean. Okay, so that is very important. So solution is prepared with the dissolving the salts in the double distilled water until the density of 1.5 gram per centimeter cube and the 1.2 gram per centimeter cube was achieved respectively, because then only it starts to flow. Okay, so that's why we are following this. And sodium chloride solution was employed instead of the sodium zinc chloride solution employed instead of sodium chloride solution for the density separation in sediment samples due to its higher recovery. Okay, so that is the reason why we are using the sodium chloride for the density separation of sediments. Okay, this is the again procedure, how much of time we have to do this. So this is the same procedure I already explained. This I am going to filtration. So this is the filter paper. Okay, so you see this. Some of the microplastics are microplastic. Out of that, a number of another product also will be made. Okay, so under the microscope only we can identify what are the particles are present there. Okay, so this is the filter paper size. Specifications are given here. Okay, so this is the diameter of 47 mm size and pore size is 0.7 micrometer for the segregation of microplastics. This because of zinc chloride has that is the rate is very high. So we have repeatedly used for 4 or 5 times we are using for that. Okay, so because of cost studies, nothing cost studies. So contamination prevention measures in our lab we are using that is every time we have to wash our cloth, that is the lab coat and the utensils with the distilled water, because of air also having the microplastic contamination. In our hands also having microplastic contamination and dresses also maybe entering into the sample means what will happen, this is the quantification we are giving to the government. Okay, so for the policy making. So if the wrong result is, it will be appear there in the policy. So for that very precaution measures we have to take for doing this process. Okay. So some of the results I have shown here. So this is the microscope we are using in our laboratory. So these are the particle size we have found. Okay, in some of the water samples and the sediment samples. So we are classifying that is the fibers, plasmas, films, pellets, and the foam. These are the different shapes we are mentioning here. Based on this, where the origin, what is the origin? If the plant means it will be cloth material. Okay, if the that is the fragments or pellet, which is from the primary source, that is the facial cream like that they are using. So what is the origin? Okay, it may be that is the primary microplastic or secondary microplastics. We have to find out with the help of these shapes. Okay, so for that we are finding the shapes. This is the magnification size of the microscope. That no need to explain. Okay, next to FTR analysis. Okay, Fourier transform. In our university, we are having these instruments. So through this, we can find out the polymer type of the microplastics. Okay, what are the polymer types? So where it is being generated, so that we can find out with the help of the polymer types. So this is the frequency. So what is the type of polymer? So polyethylene is there. Okay, so here you see this is the digital library. Library gives a that is a what is the type of polymer. Okay, so it gives that is a polymer type here. That is the these are the nanometers. Okay, so these are the information we can get it from the FKR analysis. Okay, so this we observe the polymer type that is the commonly occurring in these nanometers. Okay, so that is the important thing because of some of the library we can get the information, but we have to calculate how much range it is there, polyethylene, polypropylene. What is the range we have to know about that during our research. So for that we are classifying based on the availability of the different polymer types. So this is the one of the sample collection in the Qualitative river estuary. So these are the sample collections, and the result I have shown here. That is abundance of microplastics in the surface water and sediments. So we have done that is the how the results. Okay, how the distribution pattern will be there in that location. Okay. So we are classifying that is the mangrove region, open ocean region, and the river region. Okay, so comparing with that, mangrove region and the open ocean have high contamination comparing to the river because river is reaching into the ocean as well as in between the mangroves the roots are aerial roots. Mangroves are aerial roots, so it's trap the particles. Okay, so which is rich. The microplastics are rich in that in the mangrove root sites. Okay, so comparing to the river and the open ocean. So this the information that is the inferences from the result we are getting. Okay, so that is very important where we can say that is the ecological sensitive areas more affected due to the presence of this microplastic because of it as the aerial root. It is trapped that microplastic in that aerial root and it has the nematopores that is a which are the pores for the respiration. It will be affected that pores also which may be entering. Okay, touching that environment, that touching. So it will stop the growth. Okay, if the root because it's through that root only is respire. Okay, so the respiration will be stopped. Okay, due to the presence of these plastics, microplastics. So that is one of the study we are reporting. Okay, so what is happening there in the mangrove systems. So this is the shape. So what are the shapes we indicating? Okay, so based on these shapes, we can say that is a from near the region or the away from the region. Based on the shape, we can find out. Okay. So this is the size distribution and the color distribution pattern. Okay. It will go fast because of you are very tired. I understand that. This is another study of water quality parameters. Okay, so using the interpolation method, one of the method is there in the interpolation method. So we cannot take everywhere the samples in the ocean. Okay, in some distance, some and 1 kilometer distance, 2 kilometer distance, or 500 meter distance, this we are taking the samples. So in between how it is varying. Okay, so we don't know. So using this interpolation method, we can find out in between how it is varying. Okay, so the average calculation which is this interpolation method having different types, 4 types are there. So take the average union or intersect method. 10th we studies the union method and intersection method. Like that, it calculates and it identifies in between how much will be vary based on the available data. Okay, based on the available data, it will give the information. So this is a satellite image in the weather post. Okay. So this is the one of the studies. Salinity in monsoon season we have 5. This is another region that is the polar estuary. So how the pattern will be varying because of the locations, the sample locations are these points. These points will be the sample locations. So in between how it changes. Okay, that we can derive from the GIS software using the integration analysis. Okay, this is another LTV analysis to find out where are the places having the mangroves. Okay, this is the Kovalam region. Yes, Kovalam region. So this is the mangrove identification industry. NDA only do that where the places having the vegetation. Okay, this is the what we found that is a mangrove index area. Okay, so mangrove is only you can find. Okay, this algorithm which produce the mangrove area out of the vegetation index. Okay, so that is the variation. So from the NDA we are finding the mangrove region with the help of the histogram variation. That is the DN value variation. So we can find that where the places having the mangroves only. Okay, the mixed vegetation we are finding the mangroves only through this histogram stream. That is the algorithm. Okay, some of the our final objective is to give the awareness to the society. Okay, so we are doing some of the work. That is the coastal cleanup work we are doing. Okay. So in 2019 we did in the program beach for the coastal cleanup. These are some of the photographs for the same. Okay, we have collected some that is 1,700 kilo waste materials which we have segregating and we hand over to the municipality. So here we are hand over to the municipality. These are some of the awareness to the young generation because of they are the next generation. They have to keep our environment very clean. So in childhood campus, if we are giving the awareness to them, the action will be there. Okay, they can easily adopt and they can easily taking the action for that. Okay, so for that young generation, we have given some of the competition how we protect the environment. So this is another that is a World Ocean Day celebration, coastal cleanup. And this is one of the program we conducted awareness to the students to bring them to the SRM University, and we have given the cloth bags to them to use instead of the plastic bags. Okay, so that way we are giving the awareness to them. This is another photograph for the World Environmental Day. That is the plantation, seed balling. These are we did and giving awareness to the public with the help of that is the street drama. These are the street dramas. So they are getting some awareness. So through the drama means they will listen that. Okay. So they will listen that a lot and they are asking some of the questions also. That way they have the awareness. Okay. So this is some of the street dramas we did. And some of the newspapers they given our information. This is the patent. Okay, patent how we have to predict that is prevent the plastics entering into the ocean. This is one of the patent we got. Another one, plastic inhibitor. So it stops entering of the plastic to the ocean. Okay, across the river we are doing this. Okay, this pattern explains that. This is another pattern my students, research scholars have done. Okay, this is after treated water, we carry and we tested here. It has the sensors. If the plastics are there, it can eliminate us. Okay, so that way they are making the sensors. Okay, that sensors it shows if the plastic any foreign substance present in that water, it will eliminate us. Okay, so this is one of the patterns we are having. And this pattern that is a separation. Yes,
How many patterns?
5 and 6.
From this project?
In this project, 3 got. So this is the already we said no. That is the separation. This is we designed the separation because of already we have so much of segment separation units, but it is not good because of this we are taking that separation and that is the floating material. It will come out. That is along with the settle the sediments. Okay. But here we are having the knob here. Okay, so this knob we can close it. Okay, then we take the water. Then the sediments, the base sediments is not come out. Okay, so these provisions we are given for this alternate filtration settings. Oh, thank you. If I have any query, please ask me. So this is the one of the UK people. They are the UK people. Along with them, we are doing this work because NCCR, that is the National Center for Coastal Research, they got the project from them. They are collaborating with the UK people. That is the CIFAS, which is Center for Environmental Fisheries Aquaculture Science. Okay. So they are the people. We are together to collect the samples in the Odisha coast. So during that time, we have taken this photograph. Okay. And some of the presentations we given in the Perambur University. Yes, so that's what I have to do. Any doubt? Because of very tired, I think. So all of you. So that's why I paused very fast. If you have any doubt, Sudarshan has my number. Okay, you can get it from me. Okay. Oh, okay. இப்ப நிறைய பேர் பண்ணிட்டாங்க மேம். இப்ப நம்ம வந்து ஆல்டர்னேட் என்னன்னா எப்படி வந்து அதை வந்து அதாவது பயோடிகிரேடபிள் மெட்டீரியலா மாத்தணும், அது மாதிரி பாக்டீரியல் growth அந்த மாதிரி போயிட்டோம் மேம். எந்த பாக்டீரியா வந்து அதை அதாவது டிகிரேட் பண்ணும் அப்படிங்கிற மாதிரி.
பீச்ல மண் எடுத்துக்கலாம், சும்மா கண்ணில் வச்சு பார்த்தாலே அதுல கொஞ்சம் மண் இருக்கு, கொஞ்சம் ஷெல் இருக்கு, கொஞ்சம் பிளாஸ்டிக் இருக்கு, கொஞ்சம் நைலான் ஃபைபர் இருக்கு, கண்ணாடிகள் இருக்கு,
பலூன்லாம் அந்த பலூன் ஷூட்டிங்லாம் இருக்கு மேம். அந்த இடத்துலலாம் வந்து அந்த பிளாஸ்டிக் வந்து செதறிடுது மேம், நல்லாவே செதறிடுது. அது இல்லாம உப்பா போடக்கூடாது முதல்ல. We don't. That is we have to develop our. That is we have awareness. We have awareness. But how many people are bringing your craft bags? All are easily going to shop and getting some of the plastic bags to back. Okay. So then awareness, we are getting awareness. What is the use of this? Okay. Awareness turn into action. That is the catalyzing this theme. theme is that one. Okay, catalyzing action for ocean and climate. Already we are having so much of awareness, so much of action, so much of policies, but we are catalyzing that. Okay, for action. That is very important. Action is very less among us. Okay, today itself at least you should avoid plastics. Okay, you carry your water bottles, steel bottles. Okay, carry some cloth bags. Or your plastic bags also use multiple times. That will be little bit that is triple our concept we can adopt at least.